Unit 3 Chemistry, Chapter 9, Part 3, Secondary Cells. So this is a use of electrolysis. Secondary cells are similar to galvanic cells and the primary cells we've looked at before. So they can convert chemical energy into electrical energy. But the difference between them and the primary cell is that the products don't get used up. So we can reverse the reaction by electrolysis and recharge the cell so then we can use it again. Okay? There are some very commonly used secondary cells. You probably have some with you right now. So car batteries, lead acid accumulators have been the most widely used for many years. But there are nickel-cadmium ones, nickel-metal hydride ones that you probably have in your mobile phones and in your laptops, which are growing in their usage at an exponential rate. We'll look at the lead acid accumulator first. Okay? It's a lot of lead acid cells connected together, so it is a true battery. Because remember, a battery is many cells linked together, and we get a potential difference or a voltage of around 2 volts. The product of both reactions is a solid, lead sulphate, and it stays on the electrodes being a solid, so therefore we can reverse it by changing the polarity. Okay? It will get polarized, but you use your car battery just to start the car, and so we don't need a long-term usage. So this is your reduction half reaction. Okay, we get lead oxide reacted with some sulphate ions and some hydrogen ions, and that, in case you're not recognizing that, is sulfuric acid. Yeah, split into its ions. And we're going to make lead sulphate and water. At the other one, we're going to have just lead metal with some sulphate ions to make lead sulphate. Okay, and electrons, of course, because this is our oxidation half reaction. Okay, so the sulfuric acid, surrounding it, bathing it, it's a pretty concentrated solution, but not pure. Okay, and then we have multiple plates, which have got, the grey ones have got the lead oxide in them. The orange ones are just straight lead. They're not actually that colour, it's just to show you. Okay. To recharge it, we're going to put an external power supply on to force it to go in the other direction. Okay, so we've turned it into an electrolytic cell, converting electrical energy into chemical energy. Okay. To recharge, we're going to keep what was negative as negative, and we're going to keep what was positive as positive. But remember that what was positive for galvanic was the cathode, so that was the site of reduction. What's positive for electrolytic is the anode, which is now the side of oxidation. Okay, so it still has a plus on it, but we switched the type of reaction that's occurring. Okay? And therefore, we can regenerate it, so we can get from our lead sulphate, we can get our lead back at one electrode, and the lead oxide at the other, and we also regenerate our sulphate ions and our hydrogen ions, so we get back to our starting point.